Assuming you come across this kind of question in JAMB 2026, would you be able to answer it? Just be frank. Would you be able? Now, if you are not able to answer it, I'm here to help you. Look at the question critically. It says an organic compound contains 60% carbon, 13.3% hydrogen, and 26.7% oxygen. Calculate the empirical formula. Carbon given 12, hydrogen 1, and oxygen 6. Now, this is a typical chemistry question you should expect in JAMB 2026. Very important. And if you cannot answer this type of questions, there is no problem. I'm here to help you. Now, do you know that JAMB asks over 10 questions from organic chemistry every year? Now, this is a build-up on some of the topics I have covered in chemistry. I have told you this again and again. If you are not watching this for the first time, almost every video I uploaded, I always emphasize the fact that there are some questions, there are some topics rather, that JAMB give more attention to, that they can ask you up to 10 questions in one topic. Can you imagine? If you can master those key topics, I call them hot topics. If you can master them very well, it means that there is nothing that will stop you from having 250 and above in JAMB. That's just the fact. So, organic chemistry is one of them, and you have to give much attention to it. This first question I showed you here is a typical JAMB question 2014, and I tell you that I've observed over the years that these kinds of questions, they come again and again, and you are going to see it you yourself and testify that what I'm saying is true. So before we answer this question, now, what's the best way to play JAMB if there is a pattern that they take all the way, all the time, every year? The way to play your card is to make sure that you have identified those hot topics and you have mastered them effectively, and that's exactly what I'm doing. If you have watched my videos on variation, on other key topics where JAMB asks up to 10 questions, 7 questions, 8 questions, and even more in 1 year, you should know that those topics are not topics to be joked with. But topics where they will just ask one question, in the entire topic, JAMB will ask one question. It means they are not playing. Will you spend much hours studying such topics when you have topics where they will ask you 5, 6, 7, 8 questions and even up to 10? So this is the smart way of playing your card, but many students out there don't really know what to do. So the best way to do it is identify these hot topics, give more time to them, please. I'm emphasizing this. If you are watching this for the second time, if you are hearing this for the second time, I know to my students I've said this again and again. So for this reason, I'm revisiting this organic chemistry again to make sure that I have covered every detail, I have covered every objective that JAMB has given, everything that JAMB say you should try and know, because those are your questions. So I cannot go through under organic chemistry. This is the expectation of JAMB, and I have told you this is another smart way to play JAMB. Let me tell you, if they say under this topic, students are expected to, what do you think that is? It means those are your questions. It means you are expected to know it because hence you'll be examined on that aspect. So if you are smart enough to convert all those objectives of your syllabus into questions, and before you can move from one objective to another, you should ask yourself, at this point, am I now able to derive the name of organic compound from their general formula? If you can answer this question, I tell you, it means that any question that comes from JAMB under that objective, you can answer it. Please, I beg you. JAMB is not hard. It's just that many of you don't really sit down. You need to sit down. Just settle down. Don't rush. Sit down. Give your time to this thing and get your high score once and for all. Many students are distracted. They are not here, they are not there. They are not from one group to another. And I've emphasized it that you don't need to join many groups. In fact, I have some students last year that joined many groups, and at the end, they came back and said they wish they stayed in one group. So you don't need too many groups. You just need a strategy. You need to know what to do and do it. That's all. All right, so let's continue. So for this reason, I have begun to revise a little bit, and I'm going to talk a little today about key important things, key questions that JAMB is likely to ask you this very year, in the next JAMB that is coming up. So one important thing, and where I've seen a lot of questions, is on the fact of the tetravalency of carbon's ability to bond with itself through a process catenation. I've seen a question, and my students, you can testify, if you are punctual and you have watched all the videos I've posted, you know we've talked about catenation. So carbon compounds are too many, in billions, because carbon has 4 valence electrons, and each of these electrons must be bound to either carbon, hydrogen, or any other element. It cannot be free. So this is an illustration of carbon. In each of these structure, carbon is in the middle and is surrounded by hydrogens. Sometimes it can be carbon, then continuous chain. So this is very important. Please, if you forget anything, never forget that carbon's ability to form long chains or rings due to carbon-to-carbon bond is known as catenation. If you forget anything, never forget this. I have seen this question again and again repeated in JAMB in different ways. So please never forget this. They will either say catenation is defined as carbons dash A dash, B dash, C dash, or they would ask it in the other way. Carbon's ability to form long chains or rings due to carbon-to-carbon bond is called dash, and they will give you options. So the different ways it can come in different ways. Just master this, please, I urge you. So thank you, and let's go. So another important thing is the general formulas for alkanes, alkenes, and alkynes. You don't have option than to know this, but today I'm just going to talk about the general formula for alkanes. My concentration would be there. There are some things that I didn't include in the previous video that are here, and there are some things I included there that I'm not going to mention them here because they are not that much important. So if you have not watched the previous video, I will drop the link in the comment section, so you later, after watching this, you go and watch it. So alkanes are saturated. You must know this fact. Alkanes, ANES, the one that ends with ANES, they are saturated hydrocarbons. They have carbon-to-carbon single bond, no double bond, no triple bond. We know that those that have double bond, triple bonds are unsaturated, which are alkenes and alkynes. So these alkanes have a general formula, and the general formula is CnH2n plus 2. Whatever you need to do to master this formula for alkanes. Master that one for alkenes, master that one for alkynes also. I have seen a lot of questions, a lot, I tell you, under this general formula. And we are going to see some. And I'm even giving you assignment on some of them. So I want you to pay attention, listen to me carefully, and understand all I'm going to teach you here, so that at the end you'll be able to answer those questions easily and make yourself better prepared to get a high score in JAMB 2026. All right, so we have an example. That n represents a number. So if they say, assuming n is 2, what is the alkane? So you should be able to name what alkane, what is the compound that we are talking about. So if n is 2, go to that general formula. Wherever you see n, remove it and put 2. So for example, if n is 2 now, we are going to remove n and put 2 in that formula. So we have C2. We are going to remove n in that under hydrogen and put 2. So it will be 2 times 2 plus 2, that is 6, if you are getting me. So we have C2H6. C2H6. So you are going to use that formula. Just know that if a number is given to you, you are going to substitute it in that for n, so that you multiply where possible, where you are supposed to multiply, and add where you are supposed to add. So for that 2n is multiplication. So if they say n is 4 there, it has to be 2 times 4. Then plus the other 2 that is there is part of the formula, and it does not change. So you have to know this, very important. All right, so I think that is that. Then the next thing is IUPAC nomenclature. Yes, I have done an extensive and comprehensive lesson on nomenclature. In fact, that lesson I have covered everything about naming compounds. Please, if you are coming to my channel for this first time, all you need to do is to subscribe to this channel. Go through all the videos I've posted. You would identify a lot of videos that will be very helpful to you in this JAMB as you prepare. So thank you. So we are talking about nomenclature. I will not talk much here. You need to know how to name. I have mentioned, I have treated the rules one after the other in that video. So please go and watch it. So I won't talk much. Like I said, under nomenclature, just go and trace that video after you have finished watching this, and you see how to identify the longest carbon chain as you are seeing in this example. Your goal is to identify the longest carbon chain, then every other thing becomes a substituent. So go and watch that video after now, or rather I will drop the link. So I promise to drop the link for 2 videos now. Is it 2 or 1? Okay, so for naming organic compounds. All right, so very important here. I have seen many questions here. Please listen to me. And is the question is part of the questions I posted previously. So look at it, determination of empirical and molecular formula of organic compounds. This is very important, and you must not play with it. So if you are given a question, and I think this is the only calculation aspect of it, of this organic chemistry aspect. So you need to master this, very important. And I tell you, I have seen many questions. So what you need to do is that if you are given by the percentage, sometimes you are not given percentages. So I'm going to tell you, there are 3 categories they ask the question. They will ask with percentage, they will ask without percentage, and they will ask with vapor density. So anyone can come in. I'm going to treat some questions here as we move on so that you will master it. But let's look at this first example that deals with percentage. They say a compound with 85.7% carbon and 14.3% hydrogen, molar mass of 22 gram per mole. What is the empirical formula? So we are looking for empirical formula, and we are going to find, of course, molecular formula. So sometimes you have to be very careful, understand what they are asking you, because sometimes they can give you empirical formula and ask you to find molecular formula. So in this case, we are going to look for molecular formula. I didn't copy the complete question, but this is the real exact JAMB question that I have picked. So the first thing you do is to find the mass using the percentage, then convert it to moles and divide by the smallest mole value, then you multiply to get your whole numbers. That's if you are calculating for molar mass. Now listen, this is not complex. First thing, moles. Carbon is said to be 85.7%. So we know that the molar mass of carbon is 12 gram per mole. The molar mass for carbon is 12 grams per mole. So that's why we are dividing 85.7 over 12, and we got 7.14. Please note this. They may not give you the 12 for carbon as it is in this question. They did not give 12, so it is expected that you know. There are some popular elements whose molar mass you should know offhand. Example are hydrogen, which is 1, and carbon, which is 12, always, and oxygen, and which compound again. So you should try and know them offhand. There is very simple. So for hydrogen, the percentage is 14. So we now divide it by 1 because the molar mass of hydrogen is 1. So we divide 14 by 1. So do you see what we have now after our division? We have 7.14 and 14.3. So which of them is smallest? 7.14. So we divide each of these 2 values we got for both hydrogen and carbon by the smaller number we got, which is 7.14. And our answer is going to be, if we divide 7.14 divided by 7.14, the answer will be 1. Then for hydrogen, which is 14.3, if we divide it by 7.14, we are going to get approximately 2. So which means the portion of carbon is 1 and the portion of hydrogen is 2, which is 1:2, as shown here. So that's our empirical formula. So the empirical formula is more like the general formula for that compound. So once you are able to divide the percentage by the molar mass, then divide each of those molar mass by the smallest one you get. So you can even be given 3 elements in one compound. So in this case now we have found the empirical formula to be CH2 because 1 carbon and 2 hydrogen is 1:2 that we have gotten. I hope this is very clear. So in other cases, we have a relationship. Maybe I have a question that I've solved that have that. I would explain that much better. So let's go to it. Yes, here it is. So look at this question carefully. 2011 JAMB, you say an organic compound has an empirical formula of CH2O and vapor density of 45. What is the molecular formula? In this case, empirical formula is given, but you cannot calculate molecular formula without empirical formula. In case empirical formula is not given, it means you have to look for it if you are asked to calculate molecular formula. So in this case, what do we have? We have empirical formula and we have vapor density only. Now look at this question. Very funny. Now here they have given you the molar masses of all the elements involved. Carbon 12, hydrogen 1, oxygen 16. Do you see that? But in the previous question where we are coming from, they did not even give all this. So you have to think of 12 and 1 for carbon and oxygen. So in this case, we have empirical formula and we have vapor density, and then we have the molar masses of the individual elements. So how do we solve this? Let's go. So the empirical formula is given. So what is the mass of the empirical formula? You have to do the mathematics. Now, CH2O, we know that carbon is 12, so we have 12 plus hydrogen is 1 times 2, plus oxygen is 16. I hope these things that I'm speaking are not abstract. If you are not really understanding what I'm doing at this point, then you need to talk to me privately because you need to understand the basics. Because this thing, everyone should know them, but if you are not knowing them, it's not a crime, but you need a more close attention, and so that you can make it, because it means you have not mastered the basics. So please, if these things are not clear to you, chat me. Okay, drop it in the comment section. I would respond to you. Then I'll find a way to connect with me through WhatsApp. I will send you my number through the comment section. But if you are my student already, you know how we do it. So sorry, I'm saying my students. I have students I'm coaching for JAMB 2026, and we are working together. We have been working together, and the journey has been wonderful. Some are committed, some are not committed. I'm still open to admit more serious students. If you are serious, can complete tasks as instructed, and can do your assignments properly, you can be part of us too. So thank you. Now we have the empirical formula given, and we have the vapor density, which is 45. Now know that the molecular mass is equal to 2 times the vapor density. This is a formula, it doesn't change. You have to know that. So anytime you see vapor density in this kind of question, then know that to find the molecular mass, you are going to say 2 times that vapor density. So here we are given 45 as vapor density, so we say times 2. That will give us the molecular mass of the entire formula, not for the empirical formula. For the entire formula of that we are looking for, its molecular formula. So here now we have vapor density, 2 times vapor density, that gives us 90, and for our empirical formula we have 30. So the relationship, how do we find the multiplying factor? We divide 90 by 30. How do you know which to divide? You divide the biggest value by the smallest value. That's how you get the multiplying factor. So assuming the empirical formula, and the empirical formula can never even be greater than the molecular formula. It's not possible. If it is greater, then it means your calculations are not correct. So at this point in time, the multiplying factor is 3, because 90 divided by 30 is 3. So the molecular formula would be our empirical formula, which is CH2O times 3. We have now found the multiplying factor so that we find the molecular formula. So the multiplying factor is 3. So our correct answer will now be CH3, because that 3 would be given to everything inside the molecular formula, inside the empirical formula. So we have C3, H6, and O3. If this is not clear, because you have to know this, you just have to know this, you don't have option. Please, I beg you. The reason is because these kinds of questions come every year, almost every year. So you can't afford to miss this question when it comes up in JAMB. It's too simple to miss. It's too simple. So if this is not clear, please find a way to reach out to me through the comment section. I will attend to you and make sure that I explain it to your understanding. Thank you very much. So let's go. Another important thing that JAMB expects you to know under organic chemistry is homologous series. Now, compounds with the same functional group, maybe alkanes, alkynes, and other functional groups, and they have general formula, and they differ by CH2, they belong to the same homologous series. They differ by CH2, they belong to the same homologous series. For example, methane is CH4. So if we go to ethane, the difference between methane and ethane is CH2. So it means they belong to the same homologous series. They have the same, though alkanes doesn't have a functional group, but any compounds, 2 or more compounds that differ by CH2, they have the same functional group. It means they belong to the same homologous series. Aldehydes, ketones can differ by CH2. Different members, first member, second member, third member, fourth member, they may differ by CH2 continuously. So, but they have maintained the same functional group. Such compounds compounds are referred to be in the same homologous series. You have to know this also. An example is given there: methane, ethane, propane, butane. If you observe, the difference is just addition of CH2, addition of CH2, addition of CH2 continually. How does this affect the physical properties? JAMB expects you also to know this. So as you go, as the molecular weight of a compound increases, the boiling point and melting point are affected, including several other properties. So here I said physical properties: increase in boiling point and melting point with molecular size due to van der Waals forces. So I think I have a picture here to show you. Okay, before then, look at this illustration. Look at this. Methane has a boiling point of minus 162 degrees Celsius, which is lower compared to ethane minus 89 degrees Celsius and propane minus 40 degrees Celsius. Now, look at this negative number. So, which one is bigger? Which of them is higher? Now, it's now minus 162. As you go negative, the bigger the number, the smaller it is. I hope you have not forgot this mathematical principle. So, minus 42 is higher boiling point than minus 89. So, as the number of as the CH2 is added, which means as the compound become more complex, the boiling point increases. Let me show you. So look at this: methane, ethane, propane, and butane. Look at these compounds. Which one is more complex? Butane is more complex, so it is likely to have high boiling point than methane. And that's exactly what you are seeing here. I hope this is clear. You have to know the physical properties. It's part of the questions. Okay, so that's all for today. And I'm going to continue in the next lecture. Please, if you are really interested in learning these things, because I have decided I wanted to skip this organic chemistry because of the video I did in the past, but I've discovered that JAMB asks a lot of questions, so I cannot leave it. We have to enter deep into it. So if you have not subscribed, you need to do so, and now just hit the subscription button. There is a reason for that. I would keep on posting videos that will be very helpful to you, and I'm open to help you. My goal is to make sure that I have a minimum of 250 students to get a minimum of 250 marks in JAMB 2026. This was my goal last year. I couldn't achieve it because I started late and I had a few students as part of my group. So this year I'm hoping to scale that and to achieve it, and you would help me to achieve that if you can be serious and can be part of this vision. So thank you very much. The reason is because I've seen a lot of students out there who they have desire, they have the passion, but they lack assistance, they lack support, they lack guidance to advance in their academics. So that's why I've started this. So I hope this will help you. If you want to be part of my students, you can also indicate that I want to join your students. I would find a way to add you. Thank you very much. So this is the assignment for today. If you are my students and you are watching this is the first question. The general formula of haloalkanes. So you see the kind of questions Jambo would ask now. So that's why you need to master those questions. Haloalkanes, where X represent the halide, is now the question is very simple. Just look at the word alkanes. Alkanes. It means they are trying to test your knowledge of the formula for haloalkanes. So if you don't know the formula of alkanes, you are already lost at this point in time. I'm telling you. So all you need to do is to look at the formula of alkanes and just add your halide to it. I'm not going to say the answer here. So you work it out. Question 2, a hydrocarbon of empirical formula and vapor density. Okay, we have solved this kind of question already. So work it out and tell me write the answers and submit to me through WhatsApp, my DM, before 10 p.m. today. If you are watching this video after I've given this, you can still work it and drop it in the comment section. I will review and reply you. Okay, question 3. JAMB 2016, the formula CH2O for ethanoic acid is regarded as its So is it its general formula, empirical formula, structural formula, or molecular formula? Hi. You know, JAMB can ask simple questions, but that's if you know what you are doing. Okay. Then question 4 say consecutive numbers of an alkane homologous series differ by. Can you imagine? So do you see how simple? Hi, oh my God. See, my students. Okay, let me not say what I wanted to say. No, let me not talk. All right. So the last question 5 here. Says an organic compound contains 60%. Okay, this has to do with percentage, and I have also solved a question. We've solved a question in this video together. So go and watch it again if you didn't get it and answer this question and send to my DM before 10 p.m. today. So I'll be expecting you. So if you have not subscribed, please subscribe. Now, one thing I also want you to do is that I want you to drop a comment of an honest review. I need your help as I'm trying to reach more students, and the way you can help me is to help me get this video reach more students. I'm trying to attract serious students, and one way to do it is if you like my video, YouTube will push it to more students, and more students would see it and will watch it, and it will help them. If you drop a comment, that comment will help me and will help others. For example, I always ask students to drop an honest review because I have a goal that I want to achieve and I need to work even on myself to achieve it. Sometimes I ask them, am I fast? Am I slow? Are my explanations clear? Are you understanding my explanation? Because if all these things are not taking place, what's the essence then of posting video online? Do I just want to do what other people are doing? Nope. In case you don't know, I hold master's degree and I'm working. But why am I doing all these things? Over the time, it pains me when I see students who are serious but they don't really have enough assistance. They don't have guidance. That was what made me start this kind of thing last year. And last year, my students' result was awesome. 300 and above, 250 and above. I just have a few who had around 180 or so. I was so happy with that. So if you want to be a committed student to my lessons and you want to join my WhatsApp group of my students, you can also drop it on the comment section. Meanwhile, don't forget to like. Please like it so that it will go far. Let others see it. So you are helping others and you are helping me to attract more students who will prepare adequately for JAMB this year. And I think that is good if you can do that. So like the video, drop a comment. If you have a question, drop it in the comment section. If you just want to drop an honest review, if I'm doing well, if I'm fast based on your own learning pace, you can also let me know in the comment section. So 2 things before you go. Before you go, like this video. Before you go, drop a comment, either a review, a question, whichever way. Thank you very much and see you in the next video where we would continue from where we have stopped. Alright, so don't forget to drop your